Hey, hi, welcome everyone. Welcome to today's webinar. We would be starting in another 15 minutes. Today's webinar is on network policies. We had done one previous webinar a few weeks back, which was also related to Kubernetes, but we had discussed about security aspects and the CNI aspects in that. Today, we are focusing on network policies, securing our network. So we would give some time. We will hold on for 15 minutes around, and sharp 8:30 IST, we would be starting. Hey, thank you everyone for joining in. Thanks for showing interest in our webinar series. Today's topic is related to securing our Kubernetes cluster using network policies. On the network level, how do we secure our Kubernetes cluster? So just share your details. Tell us what made you join this session. Are you already working on Kubernetes or container itself is new for you? And what would be the next few topics in the next webinar series which you would like to uh, hear from us or you would like us to demo that? So we would be starting in another 11 minutes. Meanwhile, please introduce yourself. Thank you for introducing for the people those who have joined in, and thanks for taking out time during the weekday from your busy schedule and joining us for this webinar. We would be starting by 8:30 sharp IST. So hang along with us. Thank you all for joining in. We have around 9 more minutes to start our webinar. Please go ahead and introduce yourself. Tell us what is the domain you're working in. Are you already working on Kubernetes? Are you already securing your cluster using network policies? And tell us what has got you here today. Hey, thank you everyone for joining in. We would be starting in another 7 minutes. So just go ahead and introduce yourself. We would be starting sharp at 8:30 p.m. India time. Hello everyone. Thanks for joining in for today's webinar. We would be starting in another 4 to 5 minutes, sharp at 8:30 IST. Today's webinar is on securing our Kubernetes cluster using network policies. Thank you everyone for joining in. We'll be starting another 3 to 4 minutes. Please go ahead and introduce yourself. Tell us if you already work in containers, which type of containers you're working in, which orchestration tool you're using. Is it Kubernetes? Is it OpenShift? Which one you're working at, or you're entirely new to containers technology? Please provide your details and introduce yourself to the crowd. Hello, everyone. Thanks for showing the patience. Please go ahead and introduce yourself. And we would be starting our webinar in another 2 minutes. Today's topic is securing Kubernetes clusters using network policies. We had done a series just before to it. Part one was done discussing about the different types of networking which is possible in Kubernetes. We had seen how would the packet flow. Today, we would be learning how to isolate the communication between two pods, how to have a restrictive communication, rather, I would say. So that would be today's topic. We would be discussing about network policies. Great. A lot of people are joining in. We would be starting another half a minute. We are also live on LinkedIn and YouTube. So, in case the video in the LinkedIn is lagging, you can certainly go to the YouTube link and listen to us. The quality on the YouTube, we have seen it is better than LinkedIn sometimes. Please introduce yourself. Tell us about yourself, which technology you work in. You're using containers, you're already deploying your applications in a containerized environment, you're using Kubernetes to orchestrate them, then it's time to secure your cluster using network policies. So great, it's bang on 8:30. Let's start today's session. So as I mentioned, today we would be discussing about securing Kubernetes using network policies. We would see how we can communicate across pods, but we can have restrictive communication between them. So, to start with, I'll start with my company's introduction. We are tech scalable. We provide training and consulting services across various domains like cloud, DevOps, machine learning, data science, and AI. We do provide, uh, do a lot of webinars like this. That is also what we love to do. So, this is about tech scalable. Today, I would be the speaker for the day. I'm one of the co founders at Tech Scalable. I work as enterprise cloud architect. I have around 17 plus years of IT experience, 9 plus years of cloud experience. I love automating stuffs, and these days, containerization, migrating applications to a cloud native way is something which I love to do. So that was my introduction. Let's start with today's agenda. I don't have a agenda slide. So today's agenda is pretty crisp. It is just about network policies. So we have to discuss about pod-to-pod communication. When two application pods are talking to each other in the cluster, how do they communicate? And is there any restrictions between them when they are communicating to each other? That's the agenda. Understanding that is the agenda for today. So by default, pods are non-isolated. That means they accept traffic from any source. They would be accepting the traffic. As soon as you create a network policy, like I'll create a network policy and I would apply that to a specific pod. Resources in Kubernetes have something called as label, which helps us in identifying those resources. So we would be selecting a pod's label and we would say that this network policy would be applying to the pod which is labeled as, say, for example, app web. As soon as this policy gets applied to the pods which are labeled as app web, whatever you allow in this, that only gets allowed. Apart from that, rest everything gets denied. So pod rejects any connections that are not allowed in the network policy. So there is no deny policy. There is only allow policy. Whatever you allow in your network policy, which you have tied up with a resource, only that gets allowed. Apart from that, everything else is denied. Network policies don't conflict with each other. They are additive in nature. If I have two different network policies, they would be additive in nature. They will complement each other, and whatever is allowed in both of them, like either of them, that would get allowed. So they would not be conflicting with each other. They would be additive. I will show all these things. We will create some dummy pods. We would create some pods with which we can connect to the dummy pods of ours, and we would apply some policies and see how we can enable and disable communication between them or restrict communication between them. So we can apply network policies if we have implemented CNIs like WeaveNet or Calico. These helps us in implementing these network policies. You can use any type of cluster. It can be an on-prem cluster. You pick up 2-3 servers, you're setting up a cluster, you take AKS cluster, EKS cluster, GKE cluster, OKE cluster, any type of cluster you take. And if you have implemented Calico or any similar type of tool in it, you would be able to implement network policies in that. I'm using AKS cluster today, and I have enabled Calico on it, and I would be showing up the network policies demonstration. The same demonstration which we are doing, that can be done in any type of cluster, let it be on-prem or let it be on cloud. So let's see things in action. Just give me a minute. Let me pull up my terminal and connect to my cluster. So let me show you. I have my Kubernetes cluster, which is working on Azure. It's a AKS cluster. As I said, the same things can be demoed on or implemented on any type of cluster. I have a 2-node cluster on Azure, and it's a Azure managed cluster. Network policies have to be written. It has to be created and applied. So we would create different types of policies, and then we would see how it would work like. So I have captured some snippets which I would be implementing in the cluster, and we will see what would be the behavior and what is the meaning of the code which we are writing in. So here, if you look at the first snippet, that first snippet talks about implementing network policy. Here we have kind. Kind is network policy. That's the kind of resource we are creating. API version specifies in which version of API we are picking up. Network policy was introduced in this that we are picking up. Metadata is for this type of resource which I'm creating. This is the name of the network policy. This is the name. Web deny all is the name of the policy. Policy has a specification. Policy says on which of the pods, on whom will this policy apply? On whom will this policy apply? This policy would apply on the pods whose labels would match as app web. Whose labels would match as app web. Policies can be of two types, Ingress policy and Egress policy. First, we will see about Ingress. So few of the examples which I would be taking up would be of Ingress. So Ingress and everything is empty. Empty square braces means nothing. Empty square braces means nothing. So what we do, here we are saying that I would not accept anything. I have not specified any condition. So it is like not accepting resources or packets from any type of pods in the cluster. We are isolating that pod completely, and that's the reason it is deny. Ingress is for the incoming. So we are denying all incoming traffic to the pods which are labeled as app web. So for example, you have a pod which is labeled as app web, and I have two other pods. One is called as pod P1, another is called as pod P2. No one would be able to send packet. It would not accept the packet on this pod. It is completely denied. That is the meaning of it. So let's try implementing this. For that, we will first create a resource in the cluster. That means let us first create a pod whose label is app web and try accessing that pod from another pod. So here I'm creating a pod with kubectl run command. I'm calling the pod as web. I've picked up an image named Nginx. I've labeled it as app web, and I'm creating a service for that pod in the same command. If you say expose, it would create a service as well. Let's try executing this. If you can see, there are two things created, a pod and a service. You can do kubectl get all, and you would find a pod and a service both created. So the common use case is what we get. If we try, like very common thing what we do, to start whitelisting the traffic using network policies, we first need to blacklist the traffic using this policy. And we want to run the pod and want to prevent any other pods to communicate to it. And then whichever pods are needed, we will just allow those pods to communicate to this pod. And that's the reason deny all type of rule. So we are running a pod here, which is named as web, which has come up with Nginx image. Label is app web. It is listening on port number 80, and it has a service associated to it. It is residing in default namespace because I didn't specify the namespace parameter. Let me create a test pod. I would go ahead and create a test pod with kubectl run command. I'll say -it, interactively log into that pod. That pod will come up with a normal operating system image of Alpine. The pod name is test, and I'm getting inside the pod with a shell terminal. Shell terminal. It would take me inside the pod, and I would try to do a wget to the other application. So we know pod-to-pod communication happens via the service always. So pod, which is test, would be sending the traffic to your service of web. Web service name is just web. You can see here, the service of web was called as web. So I'm saying I would do a wget on HTTP web. That means I'm trying to send the packet to the service of this web pod. Let's try accessing. Amazing. We are able to see that welcome to Nginx page. So at present, my two pods are able to communicate to each other. I'll just come out of this pod and let me do kubectl get all. I should have the test pod and my web pod here. I would go ahead and create a policy. I've already written the YAML file, the same YAML file which I just showed, kind network policy, API version, the name of the policy which we are creating, on whom it is applicable, and from where will it accept the egress traffic. At present empty, so it would not accept from anywhere. Let's go ahead and create this network policy using the create command. I'll just copy paste this file name. If I go ahead and do kubectl get network policy, it is creating the network policy in default namespace for pods which are labeled as app web. So now this is created. If I go ahead and connect back to my test pod with kubectl exec command, and let me try doing this wget once again, and let's see what's the output. It's unable to reach because we just applied the policy on the web pod. And that's the reason it is not accepting any traffic. We are not able to see that welcome to Nginx page. This is limiting the packets or restricting the packets to going and reaching the pod web. So let me come out of this. We can go ahead and enhance that same pod with few other specifications, or I have created few dummy files which I would be executing and showing it. So I'll go ahead and delete this policy, and I'll go ahead and delete the pod as well. kubectl delete pod web, and I'll delete the service also, service web. We will create the resources once again, and we would be creating a little bit more complicated policies. Now I want to create a pod in the second snippet. If you see, I have a pod which is labeled as app bookstore, just writing it on the short form, and role API. App bookstore and role API. There can be multiple other pods as well in the same namespace. Let me draw two of them. So here, on whom it is applicable, this policy is applicable on the pod which is labeled as app bookstore and role API. So the policy is actually applied in this. Policy is applied in this. What is the policy which is applied? It is saying I will accept packet Ingress from PodSelector app bookstore. PodSelector app bookstore. For example, if this pod is labeled as app bookstore and this pod, the green pod, is labeled as app web, this would be denied and this would be accepted. We are saying we would be accepting Ingress from pods labeled as app bookstore. So this is very specific. From a specific pod, we are accepting the packet. So we are restricting traffic to a service only from other service. And for that, we are specifying the labels. We are restricting connections. You can say that the front end and the back end Backend will only accept packet from frontend. That sort of simulation we are trying to do. Let's go ahead and create a pod with the specification of app bookstore and role as API. Let's do that. So I'll use the kubectl run command. I'll call it as bookstore pod. I'll use image of Nginx. I would put labels. I have to put multiple labels this time. App bookstore is one of the label and role equals to API. I would expose it so that service also gets created. I will specify the port number as 80. Let's create it. So I'm creating the pod on which I would be applying the rules. Let me just see if it is created properly. Yeah, it's running. Now, let me go ahead and show you this file. The same one which we discussed, the same file is coded here. The network policy kind, API version, metadata, the name of the rule which we would be creating, the network policy. It is applicable on this pod, and from this pod, we are accepting the incoming traffic. Let's apply this kubectl create -f. kubectl get network policy. This policy is also created on default namespace only. Now let's see if the test pod is already running. Let's try communicating to this pod using from the test pod and see if we are able to reach. Then we would create a pod which would be having the label which this pod is expecting, and we would create one more for test purpose. So this is my test pod. It is up and running. So let me connect to it. kubectl exec-it test sh. And whom will I connect with? Let me copy this. This time it would be HTTP bookstore. That's the name of my service. Okay. Communication, not possible. I'm not getting a response from that pod. That means it is not accepting. Now, let's move out from here and create a pod whose label would be app bookstore, from which we have like plan to accept the packet. So kubectl run we will do. I have to create a pod, run -it, or rather I'll give -rm because I'm creating for the test purpose. As soon as I exit, my pod would also be deleted. Image, Alpine, labels, app equals to bookstore. I want to expose, or no, here for this, I don't need a service. So there's no point exposing it. Let me say test one. And start a shell process in it. So the pod name is test one. It is labeled as app bookstore. Now let's try communicating to this pod and see whether it responds. Yep, we are able to get the welcome to pay in Nginx page because we had accepted traffic from pods which are labeled as app bookstore. And that is the reason you're able to see this welcome to Nginx web page. So now we know from a specific pod how to accept a packet. We would complicate the stuff slowly. I'll go ahead and delete the resources which I have created. I'm deleting the network policy. I'll go ahead and delete the pod bookstore, and I'll delete the service as well. I'm doing this intentionally because when I list it, I would have multiple of them getting listed. That would confuse us. So I'm just keeping the ones which are there in the present scenario. Nothing specific. We know that the policies are additive. That's the reason it's not that if you have this policy, anything would harm. So now there are two scenarios we saw, one in which we denied packet from everywhere, and in one specifically from some specific pod, we accepted it. From a specific pod, we accepted it. Now, we want to accept packet, or from different namespaces, we don't want to accept packet. Rather, let me put it as that way. Deny traffic, but from other namespaces. So we are creating a network policy to deny all the traffic from other namespaces while allowing the traffic that comes from the same namespace that would be allowed to us. So we can create a pod, we can create resources like network policy, and we can say from where we are accepting, and from wherever you don't accept, it's all denied. It's all denied. So here, if you look at this policy, kind network policy, the API version, I am applying this on namespace default. The rule here is named as this. PodSelector labels are not there. That means it is applicable to all the pods in this particular namespace. And I'm accepting Ingress from PodSelectors, which is empty. So if I have, say, default namespace, in that I have two different pods, say labeled as P1 and labeled as P2, they should be able to communicate with each other. And if I have another namespace, say test namespace, and I have a pod over there, this communication is denied, or this communication is denied. We are denying all traffic coming from different namespace. So for that, what we did, we specified the namespace name here. We are saying that this policy applies on default namespace on all the pods. There is no selector matching labels. It's empty. That means that is applicable to all. And I'm saying I would accept traffic from curly braces. Curly braces means all. Curly braces means all. Now let's create this and see. So let's first create a pod, and then we would go ahead and create a policy. So I'll go ahead and create a dummy pod labeled web. Let me go ahead and look at the resource which is created. And we would go ahead and use that same policy, this one, to this file to create the policy. kubectl create -f and give the name of it. kubectl get network policy. Deny from other namespaces. 1 second, this. Let me clear this and get this on the top. Yeah. So PodSelector is none. PodSelector is marked as none this time. We would create another namespace. Let's create a namespace called as monitoring. And I would create a pod in monitoring namespace. I would create a pod in monitoring namespace. kubectl run -rm -it. I will provide the image of Alpine. I will give the namespace in it called as monitoring. Yeah, ing had added. The name of the pod is test, and I am planning to start the shell process. Sorry. Now from this pod, I want to get in connected with the pod, which is the web pod, and that too in default namespace. So for that, When we address a pod in a different namespace, we call it as pod name dot namespace name. Pod name dot namespace name. No, unable to connect. So it is not accepting packet from a pod which is residing in monitoring namespace. This is what we expect it to do, but let's see whether it accepts a packet from the pod in the same namespace. So we want to create a test pod and we would create it in default namespace. Resources with same name can belong to two different namespaces. So I'm creating a test pod, but this test pod is in default namespace. And let's try connecting. Okay, test already exists in this namespace. Let me see, kubectl get pods. I think it was not deleted. Okay, kubectl exec -it test sh. Why to create one when the resource is already existing? This is the previous exercise what we created. That is the one. I can also say web. If I say web, that also would make sense. If I say web.default, that will also make sense, but the default spelling has to be correct. I'm able to access the application. I am able to access the application. So with this, we understand that when I want to accept a packet from that specific namespace, any pod in that namespace, I can create a rule like this. This rule is applicable to any pod communication, but only within default namespace. It's applicable to P1 also, it's applicable to P2 also. Here we don't have a specific pod on which it is applicable. There is no label specified over there. So it is applicable to P1 pod as well. It is applicable to P2 labeled pod as well. But only those two can communicate. No other pods from outside the namespace can communicate to the pods residing in default namespace. This is one of the scenarios. Now, few other complex scenarios we would take up. Let me bring up my another snippet, which I have. Yep. So here I have few other examples. I want to accept traffic from all namespaces. I want to accept traffic from all namespaces. In that case, I would use namespace selector. In that case, I would use namespace selector. It is applicable for default namespace. Name of the policy is this, and it is applicable on the pods which are labeled on whom it is applicable, labeled as app web, labeled as app web. From where it is accepting Ingress. Whenever you see curly braces like this, that means all. Namespace selector, and that is having empty braces. That means all namespaces. All namespaces. I would accept the traffic from all namespaces. Now let's try out this with namespace selector as well. I'll just go ahead and clean up my policy. And web pod is existing. kubectl get all. Web pod is already existing. I'll not create a web pod. And a pod is existing in the monitoring namespace. If I apply this rule that it can accept packet from all namespaces, then we would be able to communicate between the pod which is residing in the monitoring namespace to the pod which is residing in the default namespace. Let's do that. kubectl create. Let me first show you the file. It's the same, which I have shown you. Okay. Namespace selector is selecting all. So kubectl create -f. Let's see. kubectl get network policy. It is applicable to the pods labeled as app web. So apply the policy only to app web pods residing in default namespace. It selects all the pods of all namespaces because the namespace selector is empty. Last time, if we just go back to the snippet, the older one, let me get that too for your reference. Here, namespace itself was not mentioned. That's the reason it didn't consider any namespace. But in the newer snippet, if you see, the namespace is mentioned with open curly braces. The namespace is mentioned with open curly braces. Later, we will see how namespace selector and pod selector can be combined. That also we would see. So here, namespace is empty. That means it is meaning all namespaces. Now we would go ahead and connect to our monitor pod if it is there. Let me see, kubectl get all, or I think I had created with -rm, so it might not be existing anymore. Yeah. kubectl run -rm -it alpine image. And I will give the namespace as monitoring. Let me copy the string and I'll name it as test starter shell. Let's try connecting to the pod. I would have to address it like this. Last time this has failed. You have seen here. This time, let's see, with this policy, will it allow? It's allowing. So last policy denied accepting packet from other namespaces. With this policy, we are able to apply and accept packet from other namespaces. Accept packet from other namespaces. So this is how the namespace selector works. Cleaning up the stuffs. Let me see what is residing. Okay, let this web be there. Maybe I'll use it in some other example. Now coming to the other one. I want to have multiple selectors. So there are or and. Two things can be done. Or can be done or and can be done. When you have or, you will have multiple hyphens like this. These are or conditions. These are or conditions. So I'm saying that this policy is applicable to the pods which are labeled this, on whom it is applicable. And from where would I accept? From the pods which is labeled so-and-so, or from the pods which is labeled so-and-so, or from the pods which are labeled so-and-so. So pods which have label of bookstore and search, or bookstore and API, or inventory and web. Either of them would be accepted. So this is the or condition. Now, for the or condition, I'm just cleaning up the space so that you can see the hyphen. Hyphen is very important. Hyphen is very important. Because of that hyphen, they become or. So if you see in YAML, when we say hyphen, that means that resource attribute is list. So I can have multiple froms like this, right? So I'm saying from this, or this, or this. That is how it is read as, or that is how it is interpreted as, rather. So we will go ahead and create resources which would suffice these requirements. Let me create first a pod which is labeled as app bookstore and role as DB, and then we would see. how to test it. Then we would see how to test it. So getting back to the terminal, kubectl run. I'm creating a DB application. Image is, say, Redis version 4. Port number 6379. I am exposing it and I would have labels. You can write that in any order. So bookstore and the other label is role DB. These were the two labels which we were planning to put. I'm putting that. App bookstore and role DB. Let's create this. kubectl get all. Container is yet under creation. Let's finish that. And in the meantime, let me show you that policy which we just saw. The snippet, I just took snippet of this file. So these are the 3 different pods from where I'm expecting to accept the packet. Let's create the policy. Sorry, I wanted to get network policy. So policy is created, which is applicable on the pod, which is this. Now let's create dummy ones. So it can accept packet from bookstore search, inventory, web, bookstore API. Let's create one from this. Let me edit this command. Role as web, app as inventory. Change the name. And I don't need to expose and create a port number and all. So I'm just going to change the image name as Alpine. I'll name it as test. And I can even create, I will have to interactively get inside it with the shell. So I'm going into that pod. And now I'll try to connect to my database. Oh, test pod is already existing. Let me create with name test1. And the default namespace test pod is already there. So my bad, I tried recreating it. Now, when I try to connect to this database pod on 6379, let's see what happens. It says it is open. It says it is open. That means I'm able to connect to it. I'll exit this. So our intention was that it would accept packet from here, which has successfully happened. Let me make bookstore and API one more combination and see. Role is API. App is bookstore. And pod name can't be test1, so it is test2. Try connecting to the database. It is open. So both the conditions matched, and each time I was able to access the pod. Now, if I try to create a pod, which just has some label, which we have not allowed at all. So I don't have matching label as app bookstores. You can't just select one label, okay? If there are 2 labels on that resource, we are supposed to select 2 labels. Let me create third pod with test3 name and try accessing now the database. Let's see what happens. What did I type? So here I should have given this rather than the output. Operation timed out. I'm not able to connect to that particular pod. So this is what expected. If the pods are not matching these three checks, I would not be able to communicate to my database. So these are my, you can say, the applications which are actually connecting to the database. So I'm just allowed it from there. API, a web microservice can connect to the database. A search microservice can connect to the database. Apart from that, no one else. So this is how the OR condition works. This is how the OR condition works. Now let's see if we can have an AND condition. We can have an AND condition. From a specific namespace, a specific pod only can communicate. So here, I don't see an hyphen. I don't see an hyphen over here. That means this and this condition are together. They are AND. We would apply this rule on pod which is labeled as app web. We would accept packet from namespace which is labeled as team operations and a pod which is labeled as type monitoring, which is labeled as type monitoring. So this is like an intersection operation. AND operator is used. So let's create a pod first, and then we would see how do we test this. App web should be there from before. Let me go quickly verify. Let's delete the last policy so that we don't confuse. So web pod is there already. I don't think anything else is needed for applying this policy to it. It already has a label as app web. So we would go ahead and create the resource from the file which I just showed you. This was the file having two sections, and they are two conditions are AND in this. kubectl get network policy. Sorry, it is having app web selector for the pod. I'll just clear up the screen. So policy is created. Now we need to test our condition. We need to test our condition. So if it is in default namespace, any other labeled pod, will I be able to communicate? Or if I'm in operations labeled namespace with monitoring labeled pod, I would be able to connect or not. That's our check, which we have to do. That's the check we have to do. Now, if I go ahead and create, I think I have a test pod already. Let me just list that. I would connect to my older test pod, kubectl exec-it. You connect to test 1, test 2, anything. All are going to mean the same this time because all of them are residing in our namespace default only. I'll go ahead, wget I need to type. And I am in the same namespace, so I'll just write web. Nope, I'm not able to connect to. I am not able to connect to. So I'm having a timeout because I am not able to reach that particular pod. It's not accepting the packet from me. If I try to create a pod which has label of type monitoring, let's see what happens. It would be in default namespace, but the label would be type monitoring. kubectl run. Test 3 was there. Let me create test 4. Labels type equals to monitoring. --rm -it image alpine and shell. Oh, ---- image is needed. My bad. Let's try accessing. We are in the same namespace, so we don't have to give default here, or else we would have given default. But that is also not making us reach that particular pod. Type monitoring, that means it's not a and or condition, right? We tried meeting this criteria, but our packet was not accepted. Now what we would do, we would first create a namespace, we would label it, and then we would go ahead and try accessing. So our namespace name has to be operations and its label is team operations. Let's do that. kubectl create ns. I'll just add in the label to it. Metadata is there. You can add label here to the metadata section. I will say labels. Go to spaces inside and then say team operations. Let me just quickly verify from the snippet. Team's operations is the label of the namespace. So team operations is the label of the namespace. Fine. Now our namespace is having a proper label as well. Now let's create a pod in this namespace. So I will copy this and I would give the namespace parameter in this. I will give the namespace parameter in this. Name of the namespace is different, label of the namespace is different. Okay, so don't confuse with that. My namespace name is operations. My label is type operations. Let's create this. Oh, I have copied the wrong one, which had not worked out. Hyphen was missing in it. Just adding that and re-executing it. It's working. If I just put hyphen like with web, bad address, there is no web named pod in operations namespace. So when you just give the name of the namespace, it goes to that DNS, core DNS, and it asks for web named pod. It will say web.operations. Nothing is existing. But web.default is the one which is actually existing, and we had applied the rule to it in default namespace. And we are able to communicate with it. So these are some of the examples of ours with respect to the Ingress traffic. Oh, I'm inside the pod. So today's would be a small session because network policy is not that complicated. Like I would say it is a complicated topic because you can write n number of policies, but I don't have that much stuff to cover in it. I'll go ahead with egress traffic now. So we can create network policies which would be applicable to ingress traffic and to egress traffic as well. So we want to deny egress traffic from a specific application, or we want to deny from all applications. So when you want to prevent an application from establishing any connection to the pods, to outside of that pod, you can apply that deny egress type of rule. Deny egress type of rule. So let me create a file for it, say deny egress. I don't have a readily available YAML file for it, so let me code that and let's see it here itself. Kind is network policy, metadata, the name of the policy. Pod selector, it is applicable to the pod which are labeled as foo. So it is saying foo deny egress. Outgoing packets would be denied. Whenever you see square braces empty, that means nothing. Whenever you see curly braces empty, that means all. So here it is no more ingress. This is only egress. This is only egress. I can have combination of egress and ingress both. I can have combination of egress and ingress both. Egress, it is having a empty. So pod selector is matching app foo pod. Egress policy indicates that the policy is enforced for the egress traffic or outgoing traffic or outbound traffic, whatever you would like to say. Empty braces here, empty rule set does not whitelist any traffic. Therefore, all egress going out from this particular labeled pod would be blocked. Would be blocked. Let's try creating that and see how it works. So this time I'm first creating the policy. Then I'll create a pod with label foo. I've not done that. Then I'll go ahead and create a pod with app label foo. Sorry, run command. I will name it as web. Let me name it as web. And then I'll give the image as Nginx. I will have port 80. I will say expose. And I will label it as foo. I'll label it as app as foo. Labels I have to give. Keyword is labels. It's not label. App equals to foo. So the rule is applicable of web is already existing. Let me just clean up the previous ones. kubectl delete pod web. Let me call this guy as foo instead of web. So foo is created. kubectl get network policy. A rule is applicable on foo as well. And from this particular pod, you will not be able to communicate outside. You will not be able to communicate outside. So let me see what other pods are existing. kubectl get all. Some test pods were there. We can try to communicate to that. Let me create a app web pod. I can try reaching web on port number 80. It became wed. Okay, I'll use wed then. So now dummy pod is there to which I would try to connect from my foo pod. So let me get inside it. kubectl exec-it foo with an sh. Now let's try doing wget. Wget on HTTP web. wget is not found. What type of image had I picked up for Nginx? It was Nginx. Okay. Okay. I should have taken that as foo. No worries. This is which OS? Let me check if apt update works. Yep. I'll install wget in this. It's still connecting. It's unable to resolve. So let me kill this. And create one proper one. kubectl delete pod foo. kubectl run foo -it. -it. And I would give image of Alpine so that I would be able to send packet using wget. And what else I have to give? Label. And I will give a name. No, I've given a name as foo already. So I'll say sh. So the rule is applicable on this pod. And from this pod, we should not allow any packet to go out. It's unable to connect to the web. No packets are going out. It says bad address. What is meant by bad address? It can't even communicate to our DNS pod. It can't even communicate to our DNS pod. It is not able to resolve. It fails to resolve the address because the network policy is not allowing it to have connections with the core DNS pods. That's the reason it is unable to resolve. It didn't say I can't reach that, right? No timed out didn't happen. It says bad address. So let's try and edit this policy a bit, okay? We will go ahead and edit the file which we had created. This is the one. I would allow the packet to go to the DNS, but not anything apart from it. So let's see how do we write the port specifications as well. So we can also control the packet which goes on a specific port number, a specific type of protocol. Okay, so port number for the DNS communication is 50 and protocol, I can write it as UDP. I can also say port, I have to write not ports. Okay, I made a mistake here. Ports I would specify, and then this is a list again. Port. Yeah, this is correct. So I have multiple ports inside Egress. This is a list. First port is 53. Protocol is UDP. Now I would write another port number. Spacing is very important in YAML, that we know. So just keeping an eye on that. Protocol, don't you guys think it has to be aligned like this? Yeah. Protocol as TCP. So this time it would be able to allow for DNS resolution, but it will not be able to communicate to the pod, which is like any other pod apart from the DNS. So let's try applying this. I've changed the file. I need to apply kubectl apply -f because I'm changing the existing network policy. Let's apply these changes. There's some YAML error on line number 13. Let's see what is line number 13. We have made a mistake. Oh, there is a colon missing here. Yeah. Every time key and a value has a colon in between it. So it is applied. Don't go by this. It's okay. Here it says it is configured. If you want to go ahead and just check that whether what you applied is proper or not, you can even go ahead and edit network policy, give the name, and give the name of it, foo deny egress. This was the name of the policy. It is applicable. The changes have taken into effect. I'm just quitting. I'm not editing anything. Now I would go ahead and connect to that pod again. I had started with --rm. No, that means my foo is existing. kubectl get all. Yeah, foo is existing. Let me just pick up this. kubectl exec -it foo and sh. This time it would not say bad address. It will actually time out. It will time out. I can give the timeout seconds as well in this command to see whether it really gets timed out. You can write --, timeout. Wget download timed out. So we are unable to reach. And the traffic will not go anywhere. Entire traffic is blocked. Entire traffic is blocked. Like if I want to access anywhere outside as well, like for example, http techscalable.com, like www.techscalable.com, if I try to do this, this also would be blocked. It would not be able to reach. I would not be able to ping to google.com either. Normally, inside the container, we are having that connectivity. We can connect outside. Ingress is not default. Any ports are not opened, but egress is. Here, that is not also allowed. So this is about few of the complicated stuffs. You can see here that we have tried executing quite a few number of scenarios and options, the egress traffic, ingress traffic, a lot of combinations we picked up. And this is how the policies are implemented in the cluster and they are applied to specific resources in the cluster. Specific resources in the cluster. So I fear today's session was pretty crisp and small. It was just an hour session. And let me see. Let me showcase what next is coming up. Few other webinars or few other upcoming trainings which are coming up. So we have an upcoming session for CKA and CKD. Today you saw a glimpse of our Kubernetes training. We cover network policies in our CKA program. So you just saw a glimpse of it. So this is how we conduct our session, interactive session with demos, with a lot of drawings, explanation and all. Our session starts from October 2nd. There is another batch also starting. We are also doing Google batches, Associate Cloud Engineer. And that is also starting from October 2nd. Google batches are for 5 weekends and CK and CKD program is for 10 weekends. So if you have any questions, you can post our questions. We would be responding. Team was responding at the back end in case some questions are missed out. We would certainly get back. I would spend some time now on LinkedIn and YouTube and respond to those questions. In case you're interested in any of our sessions, attending our paid courses like the CKAD or the CKA batch, which is happening, you can connect to us on this number or you can drop in a mail to our sales team at sales@techscalable.com. So this was all about today's session. We tried learning about network policies. We plan to actually do both the sessions together, but this webinar would have like gone around 2.5, 3 hours, and people don't have that much of patience in a single stretch. So we tried dividing that into small parts. And that's the reason today's webinar is just an hour. Hope this knowledge helps you. In case you're interested to get in touch with us, do connect with us on our LinkedIn page. Follow us on LinkedIn, Tech Scalable's page. We keep doing such good webinars. You can like enroll for the upcoming webinars as well. You can follow us on the LinkedIn page and see what new things we are getting in. A lot of posts we keep doing about the latest technology terms and all that, which simplifies the understanding. So stay connected, I would say, and thanks for attending. Thanks for taking out time during the week and attending our webinar. Hope it was fruitful for you. So team, I think we are good to close the session. Yeah. So thanks a lot, guys. Take care and stay safe.